Okay, so I think I'm going to very tentatively start the webinar. So first of all, welcome to everyone again. This is the second webinar in our 6-part webinar series on Anemoi, entitled Discover Anemoi. And the webinar today is about datasets, Anemoi Datasets. This follows up from the webinar on Monday, which was the introduction to Anemoi presented by Jesper Dramsch. And if you look on the right side of the slide here, you'll see the other webinars in our series. So on the 21st, that's next week, we've got graphs, followed by training on the 23rd. And then the week after that, we've got 2 more webinars, one on inference and one on developers. All of our webinars start at 3 o'clock Central European Time or 2 o'clock UTC. And the registration and all the details about these webinars can be found at the same event page where you will have gone to register for this webinar. So I've left the QR code there. I've left the link here as well if you want to go back to that. Just to point out that the registrations do close around 2 days before the actual webinar starts. So for next week, please, if you want to attend those webinars, please register as soon as you can. And yeah, just to say a couple of things before we start. One is that the questions, as last time, you can leave questions in the chat, and some of our colleagues will try to answer them in the chat. But there will also be time at the end for further questions, potentially with going on video if you want to raise your hand. And the webinar will also be recorded, and we will make the video available afterwards. So if you see my slide, you'll see that if you now go to the event page of the Anemoi webinar series, you'll find in this small, oh, sorry, someone doesn't see the slides. Baudouin, do you see the slides?
Yeah, your slides, yes.
Okay.
I see slides too.
Okay, it sounds like most people can see the slides. I'm sorry if someone can't see that. Okay, it seems most people can see them. So maybe there's someone just with a problem. So thanks for the thanks for the confirmation. Okay, in any case, as I was saying, the webinar recordings are now available here on the event page, and if you go to that link, you will see the slides and also the recording, which is on YouTube. So we will put up all these recordings as soon as we can afterwards on the event page. And so I think that's all that there is to say, and I would like to now hand you over to Baudouin, who will tell you all about Anemoi Datasets. Over to you, Baudouin.
Okay, okay, do you see my slides? Okay.
Yes, so we see them.
Anemoi Datasets is the first package of the series of the Anemoi packages. And this is a package to create and use datasets for training machine learning weather forecasting system. So the goals here is really to create a machine learning ready dataset for training data-driven forecasts. And we want to make the loading of data samples as efficient as possible, because you don't want reading data from disk that will actually starve your GPU. You want the GPU is an expensive resource, and you want to make sure you feed the GPU during training as efficiently as possible. We also want to provide rich metadata that will be used by the other Anemoi packages, especially training and later inference. So what this is not is a replacement for the original data source. So if you create a data set based on some sort of archive, or like, for example, we do with ERA5, these data sets, we see them as temporary. Again, what is very important is that you have to see them as pre-processed data so that the training is as fast as possible. We keep all our source data, and we can delete and recreate data sets in the sense of Anemoi as we see fit. And I will show you in the second half of how we create data sets. So how does it work? So for us, a sample in terms of training is the state of the atmosphere at a given time. And we train the model so that when we get a state at time t, we want to get the state, we want to forecast the state of the atmosphere at time t plus 1. And the state of the atmosphere for us is all the meteorological variables, which can be surface variable and upper air variables. So in a nutshell, what we try to achieve here is that if we have a data set DS, we want to be able to read X, which is the input, Y, which is the output, run a model to predict Y from X, sorry, and then compute the loss. So that's the goal, is that when you go and access the data set, everything should be as efficient as possible. A data set like ERA5, and we discussed that on Monday, is too large to fit in memory. So our largest data set, for example, we created this is in the order of 40 terabyte. So the data needs to be on the file system. And again, we want to create a data set where the input output from the disk is as lightweight as possible. So for us, we found that ZAR is the best fit for our requirement. So ZAR is a table that is, if you want a big array, which is backed onto a file system, it looks like an NumPy array, and is compressed. So it gives you an array-like view of a collection of files, which are called chunks, and we want to define an array which marks exactly the sample we want to feed to the GPU. And in the way we do is also each file on disk is a single date, or the time t as you saw before. So we decided on a 4D structure. The first dimension are the date. The second are the variable. The third one is the ensemble dimension, because we do ensemble forecast. Most of our data set has the dimension 1 here. And then we have the grid point, which we also flatten. That means we don't keep the structure of the grid, because we actually use later a graph, which actually during training keep track of the geographical location of the points. So we don't need to keep them in a data set. So it's very simple. As you can see, and when I mention dates, I'm talking about date time, which is a point in time during in your data set. Okay, it's not just the date, but the date with the time. So I will start with how we use the data set, and then I will go to how we build them, because I think using is an interesting aspect of what we are trying to do here. So you will simply, there is only one function from Anemoi dataset, which is to open the dataset, and you get back a variable. Of course, all the examples here are in Python, by the way. So we open the dataset with a path, and then you have most of the NumPy function of the NumPy array. So you can get the shape, you can get the number of rows, and then you can get the first date by ds of 0, or you can get a slice of dates 10 to 20, and so on. I will have a slide to go more in detail of what we do. But that's in a nutshell what we want to achieve. Very simple vision of an array with all our samples. One of the main features of the Anemoi dataset is that you will, when you open an existing dataset, you have the ability to subset it or to combine datasets. So if you created a dataset which is not exactly what you want to do, you will be able to, when you use it, to actually change the way you want to read it. And I will get back to those details later. So, and usually the way you open a data set, you pass a data set and a collection of options directly in a command line as arguments to the open data set. But you can also pass everything as a dictionary, and we will see that is actually the most useful way of building on the fly parameters that you can pass to open datasets. Your dataset can be files, can be URLs, and can be URLs as a HTTP URL, but can also be hosted in the cloud with the S3 protocol. This is all supported by ZAR out of the box. So we rely on the ability of ZAR to read data from several sources. There is another way also of which we recommend is that you can have a config file in your home in which you name datasets. So you can either give a path or you can give names to datasets, and then you open the dataset by name. This is very useful when you want to move files, move code from across various sites. So if you have some code that reads a dataset by name, open a dataset by name, you can have a different config on different sites and find the same dataset. So you don't have to hard code the path in your code. You can also open a dataset in the code and use it to open a secondary copy of this same dataset by providing subsetting operations, for example. Now, what I was saying is that the way you build a selection of a combination of merging dataset and subsetting datasets when you open one could be as complex as needed. And this is what our researchers are doing. We have a catalog of datasets, and they start to mix and match existing datasets. And these are virtually viewed as a single one. Therefore, when we do training, whether you train from a single dataset or a combination of various datasets with subsetting, the training code is completely unaware of that. So mostly what we do, I mean, it's not exactly like that, but when we do training, we have a big config file, and actually the way datasets are described, they are described in a config file. In the case of training, the config file contains more than just a dataset, of course, but that's give you an idea of how we plan to use how we use Anemoi datasets, mostly using config file to define our datasets. Now, subsetting. So I'm going to go, you can subset a dataset by changing the starting date, end date, or give a range. And this is how we usually do training. So we have often we train on ERA 5, which is 45 years. And people select the first, let's say, 40 years for the training. And they use like 2 or 3 years for the test and 2 or 3 years for the validation. And that they do that by simply subselecting different ranges of dates from the same data set. We use shortcuts like here a date, but you can give a date and months, you can give a full date. Usually people, when you have a 45 years data set, tend to think in whole years. They don't go to the granularity of an hour when they are going to select a training or a test data subset of the data set. You can also change the frequency. So when we build datasets, we build dataset usually either 6 hourly or we build dataset 1 hourly, depending on the source of data. You can also change the frequency. So if you have a 1 hourly dataset, but you only want to train your model on a 6 hourly increment, you can do that by simply changing the frequency. Again, what I'm trying to show here is that all that is virtual. So when you are going to iterate through the dates, you will iterate through the dates 6 hourly at a time. And because, for example, in that case, the dates are, each file is a date, or each date is a file, you are not going to read unnecessary data from this when you subset in time like that, okay? We have been asked to do the opposite. That means if you want to go below the original frequency of the data set, you can give you can interpolate in time. So this is a very, very simple linear interpolation of the data value between original dates. Now, the second dimension of the data set was the variable. All those variables are simply named by strings. Here, this is the vocabulary we use at ECMWF, but actually the strings have no semantics. They are just strings. This is how you name your variable when you build your data set. You can select a subset of variable if you just want only two here. So in the first case, you give a list, and the list will also give the order in which you want this variable to be selected. If you give a set, they are just selected in the order they have been put in the file. You can also do the opposite, which is to open the data set and drop the variable you don't want to use. So when you then iterate your data set, you will not see those variables. You can reorder. I mean, this is just for the sake of completeness. There are many things you can do. All those operations are very useful in combination with the next operation will be to combine data sets. And you can rename variables, okay? So if you have a variable called 2t and you want to rename it 2tm, you can do that when you open. And that's very useful when you are going to combine data sets. That happens to have if you want them to have the same vocabulary. And you can rescale as well. That was, again, because when you combine data set, you may have temperature in Celsius, temperature in Kelvin, and you want to combine them into a common set of units. Okay, under the rule that uses the UD unit, so it only implements linear conversion. Okay, so only something like AX plus B. That will not work if your conversion is not linear between the units. And members, again, you can select one member, three members if you have a data set that contains several members. Now, you can also open two data sets like that by passing two in the command line or a list. And the meaning of what opening two data set means is actually depends on the data set. So if the data set have the same variables and the range of dates of data set number one is followed by the range of dates by data set number two, or three or four, you can concatenate, you can merge as many data sets as you want. They will be concatenated. Again, this operation has no cost whatsoever. It's just a virtual operation. But when you are going to scan you are going to go through the list of dates of this concatenation of data sets. You will go through all the dates, all the rows of the first data set, and then follow it with the rows of the second data set. And that is also useful when you want to create data set for, let's say, a 10-year, and then later you want to extend to another 10-year. You don't need to recreate the full data set over 20 years. You create yet another data set over the next period, and you simply concatenate them virtually by opening them in the same open code. Now, if the dates are the same, but the variables are different, then they are joined against the second dimension, which is the dimension of the variable. So you can create again a virtual data set, which will contain a list of dates and the list of variables from two or more data sets you can read. And if the second data set happens to have variables which are in the first one, they will occult or override the first data set. So you can Remember the fact that you can rename datasets, rename variable, you can reorder variable. So people actually, sometimes they have a data set where they say, for example, they have an SST in the data set, but they want to try to bring an SST from another data set because they believe that this other data set will have a better SST. They will simply combine the two data sets by overriding the sea surface temperature of the original one with the sea surface temperature of the secondary data set. And because those two operations I showed before either needs the same sort of dates, and when I say dates, I mean dates and start date, end date, and frequency. In the case of the join, and in the case of the concat, they need the same variable. You can ask the open data set to adjust the dates or the variable or everything so that automatically the common list of dates is used and the common list of variable. So the intersection of variable and the intersection of dates are selected. So you can combine a data set without worrying about overlap or common list of variables. Now, we have also a couple of other combinations we do. Again, remember, this is done on the fly as you read the data from disk. It's not done at creation time. One we called cutout, and that has been used by people who want to run a limited area model and global data sets. So the red grid is the global data set, for example, ERA5, and the green grid is a limited area model. In this case, it was a limited area model from Met Norway. That's why it's over Norway. And then you can cut out this shape of the limited area model from the global model, and then they are combined at the level of the grid. So in that case, the fourth dimension of the dataset will simply return a list of grid points and values which are combined, which are the combination of both grids with the green, if you want, the high resolution LAM over Norway, and the lower resolution ERA5 over the rest of the world. You can also do some thinning. This is mostly used by people who wants to have a data set with a high or medium resolution, but they want to quickly prototype some model. So you can remove lots of grid points from the input, and that's just more like a development / prototyping tool. So you can work on your training, have a fast training because there are few points, and then when you're happy, you remove the thinning. And the last one is also the ability to extract a subarea from a bigger grid. I don't think anybody has used that feature yet. Now, what I was saying is that once you have opened your data set, it supports most of NumPy's indexing and slicing. Okay, so you can iterate through the data set. You can get the first date. You can get 10 dates, 5 variables, and the rest, and so on. I think the only NumPy indexing feature that is not supported is to index with an array of Boolean. But all the others, all the slices and indices should work. Be careful if you do. You can easily have if you do DS colon, for example, that will load the whole data set in memory. So the plan, although this is valid, usually that will crash your software. The idea is that really, because the first dimension is the date, is that you are supposed to iterate through this data set using the date dimension. Now, in addition to the NumPy attributes, indexing, you have a few attributes. So you have the shape. The shape in that case will be the shape of the NumPy-like object. So 4, it will be a shape of 4. The field shape is the shape of the original field. I remember that we flatten all the fields. So if your field was a 2D field, you can recover the shape of the original field when you create it. The D type, which is the same as NumPy. Dates is an attribute that will contain the NumPy array with all the dates of your data set. So if you want to know what is date, the first date, you just use that array and index it with 0, and you get the first date. And the last date, you do the same with -1. Frequency is the distance between two dates. Currently, those dataset needs only works with the regular frequency between dates. This is something I forgot to say. Okay, so dataset must be hourly, 6 hourly, 12 hourly, daily, and so on. Latitude and longitude are two vectors, NumPy, which will return the list of latitude of longitude, so you can recover the position of the grid point. And this, for example, is used to create the graphs. Statistics, I will introduce that in the next slide. The resolution of the data set, this is more like a string. It's not very useful, but eventually we will work on that. It was to describe what was the resolution in terms of degree or kilometers, but that's not very standard, so we need to find a standard way to describe the resolution of a data set. Name to index, if you have a variable name, it gives you the index in the second dimension. Variables is a list of variables, and missing is the list of missing dates, and we will discuss that when we create. We are going to talk about creating data sets. So when you have a data set, you can recover the statistics. So you have an attribute called statistics, and we collect 4 statistics, which is the average, the standard deviation, the minimum, and the maximum. And then again, with the name to index, you can, there is a typo, it should be square brackets here. It's not a function, it's the dictionary. Then you can get back to the statistics for that variable. So when we create data sets, we collect statistics. So when you can use those to normalize your variable during training. Because again, those statistics or those data sets can be very large in the order of terabytes. So you don't want to have to scan the whole data set to compute the statistics. Now, if you combine, there is a limitation here. If you combine many data sets, only the statistics of the first data set in your list are used. So a few examples here. I want to show you how people use. These are real life examples of training we have done. So you have the code in Python on the side, and you have a sort of a flow chart of what is actually happening. So in green are the data set, in bluish are the function. Okay, so the code on the side will open 2 data sets. One is from operational analysis. The second one is a data set that only contains precipitation. And then the first one will drop a few variables, will select the frequency and then end, and combine that with a secondary data set which only contains precipitation, select one of the precipitation, which is called in this data set TP from 0 to 12, and rename that data set to be called TP. And then you see the arrows actually represent the sort of flow of data to create this virtual data set. Another interesting one, which is using, sorry, I think I pasted the wrong plot here. So that was supposed to select data from a land model and combine it with the operational analysis. So I'll skip this one. And here, this is a very complicated one where we combined a data set from 1950 to 78 and a data set from 78 to 2023. And a few variables are dropped. And then the selection of date is done. And that is fed to the training. Okay, I will skip this one. Yet another one. Here, this is mixing data from ocean data. So a lot of sea ice and the, I think, ice caps, ice. And this is mixed with normal atmospheric data. And people have been training a model with both the source of data. Now I'm going to go to the second half, which is building data sets. So the way we want to build a data set is we have a recipe, which is as a collection of operations you can do, and then is fed by dates. So the driver, when we create a data set, is really the list of dates we want. And then we pass those dates to different operations that will are supposed to convert these dates into a list of fields, which are then stored into the ZAR according to the dates. So very simple YAML file. You have a list of dates, start and end, a frequency, and then you have an input. In that case, it's a gray file. You have a path to the gray file. You have the list of parameters. So that's a very tiny YAML file. And then you use Anemoi Dataset, create, you pass the YAML file, you pass the name of the ZAR file, and it will run and create that ZAR. So the block date is as follows. It has a start and an end, a frequency. And the group by is more by the batching of dates we are going to do when we build the data set. So this group by is mostly used during the build, just to, the default is to take 1 month of data, go and get 1 month of data, put it in a ZAR, go and get another month of data. Sometimes your data or your source of data is too big or too small, and you want to change the grouping of the dates by which you build a data set. What's very important is we use valid date and not reference date. So not a lot of people know the difference, but when we do weather forecasting, the valid date is the date at which the data is valid, which is if you have a forecast somewhere in the future. Reference date is usually the date at which you start your forecast. So everything here is driven by the date at which the data is valid, okay? I just put that as an aside here, but most of the people don't have this issue here. It's only people doing forecasting. There is also in the YAML, you can have an output block. That's the default. The default is to encode everything within float 32 and to chunk by date and ensemble. So that you can tweak that if needed. That's just a default, and I put that in the slides for reference. Now, the variable, I mentioned that they are just strings without semantic. You should not give any semantics to the strings. I mean, they have a meaning for human being, but they are just strings which are used throughout Anemoi. So as long as you use the same name throughout the processing, it's very important. When you are going to do some training, you are going to give a name of prognostic, diagnostic variable that you want to use, and they should match the same name. But we don't apply any semantics to the name. So you can have names which are your names, doesn't matter. The only thing I have to say is that we, by default, we take the name of the variable and the level, so we combine both. So if you have a temperature over 850 hectopascal, in our case, it will call T_850, and that's the default. We don't keep the 3D aspect of the variable. We flatten also the variable space. Remember, we have only 4 dimensions: the time, the variable, the ensemble, and the grid point. We let the model discover the vertical structure of the atmosphere. You can change the naming method. Now, what I have to say here, I will show. We support GRIB and HCDF. Both have a slightly different sort of naming conventions. So we have a few synonyms like param for GRIB and variable for NetCDF, kind of been the same thing, like level and level list. This is a sort of work in progress. If you stick to one GRIB or stick to NetCDF, it should be fine. When you start mixing both, it kind of, you have to be careful. But we are working on that. Remember, this Anemoi dataset is still a work in progress. We still have not reached version 1.0 of the code. Now, operation, I said, a block of YAML that translates a list of dates into fields. So the simplest operation will be simply to read the source of data. Like, again, I give my example of a GRIB file here and 2 parameters. And that will try to extract the parameters from that GRIB file. You can also combine several sources of data. So imagine you have data in one database, some more data in another database, or several files. You use the join, and then each source will have, again, will have to be listed. So the join is just to have several sources, and each of them are supposed to retrieve different variables for the same dates. The other one is the pipe. So usually you have a source of data, and then you apply a couple of filters, and I will express because the data you have in your data set is not exactly in the shape you want. And concat is if you have different sources for different dates, range of dates. That happened with one of OpenDAP source where they changed the URL of the data sometimes during the creation of their archive. So we needed to say for that from that date to that date you use that URL. From that date to that date you use this other URL. So again, this is just to filter to let you build data sets from several sources. We collect the statistics. So we don't compute the statistics on the whole data set, only on 80% of the data set. So there are a few rules which are documented here. You can also control on which range of dates the statistics are computed. By default, if your data has missing value, which are nans, the statistic will fail. So you can allow the use of statistic. It's more like a protection that you don't accidentally ingest data with missing values. We also compute increment of statistics. I will not dwell on that, but some people want to use the statistics of the difference between 2 dates, so or two different time steps, and they for their model. So we also provide those statistics if needed. Missing dates needs to be unfortunately listed in extension in the date block. So if you have a data set with way too many missing dates, it won't be useful. So our assumption is the list of missing dates is smallish. And then so remember, you still have a start date, end date, and the frequency, and you just list the missing dates. So the system will ignore them, and they will be the ZAR will be filled with nans. They will not be considered computing the statistics, and you can get back the list of missing dates or indices of missing dates. And if you happen to actually try to access a date which is missing, the system will throw an exception, missing date error when you use the dataset. Now, sources, we have a few of them. general purpose. So we have grid because at ECMWF we use a lot of grid, so we have that. NetCDF, OpenDAP, and Xarray ZAR are all under the hood the same source because they use Xarray as the driver to read data from NetCDF and OpenDAP or ZAR in the cloud. But they have their own independent source description in the YAML. So for example, NetCDF will expect a path, while OpenDAP will expect a URL. We've been playing with things like Kerchunk or Zenodo, just experimental. I don't think anybody uses those things, but it's just as a proof of concept that we can have several sources. If the source happens to be a file or a URL, you can also use Unix wildcard. So if you have a directory with lots of grib, you can pass all the gribs in with the star. Or you can also, if you have a naming convention in your URLs or files, you can use the param or the dates to build the path or the URL. So in the first example here, the system will open data-u.grib and data-v.grib to find each of the parameters. In the second case, it will load a path from try to find the data given the date, which is the one we want to fetch from, and then we'll use the Python strf time function to format the date into a string. Xarray-based sources, as I say, we use Xarray for all things NetCDF, OpenDAP, ZAR, but we expect those sources to follow the CF convention. The vocabulary is slightly different, and we let you pass options to the Xarray, OpenZAR, or OpenDataset. And unfortunately, playing with lots of NetCDF files or ZAR files, they are not always all following the CF convention. So you have two more ways to control. You can patch. You can give a dictionary that will sort of add missing attributes to the data you are loading. So like, for example, standard names or units, so we can find the latitude, longitude more easily. Or also describe in a flavor, like, for example, how the data set is organized. Okay, this needs to be more documented. It's actually somewhere in the test, you will find how to define flavors and patch the data sets. Now, these we have a few sources specific to ECMWF. So Mars, which is our archive, and accumulation as well. And I will skip those. If you happen to have access to ECMWF, you can use those sources to get data from the archive. And then we have three specialized sources, one to recenter ensemble over another mean. So for example, usually the ensemble, if you have an ensemble, it's centered around the mean. But if you want to recenter it over another source like the operational analysis, you can use this one. Repeat data, I'm going to describe it in more details, and forcings as well. So forcings are fields which are built on the fly. They are not read from any file, and they contain information about time and space. And I have a table here. So you can create a field of latitude. So imagine in your data set, one of the variables will be called latitude, and it will contain at each grid point the latitude of the corresponding grid point. This is not very useful because it's not periodic. So we use the cos of latitude, the sin of latitude, same for the longitude. We also have the Julian day, which represents the day in the year. We also have the local time, which represents the time of the grid point. And again with the cos and the sin, so we make them periodic, and we have the insolation. So these ones are sort of artificial fields that we can add to the data sets, and they help the neural network to find its bearing in time and space. They are very useful. Repeat date is if you have a data set which, like an orography, just a single file with an orography or bathymetry, and you want that to be available through all your dates, you will use that source, which will repeat a single field throughout all the dates. Same with climatology. Climatology are mostly when you have 12 values, one for each month of the year. You can load for each month of the year in your ZAR this value. Or if you have a data set with lots of gaps, you can ask the data set to be filled with the closest date that matches the date we want to load in the ZAR. Okay, this one I will skip. Filters, we have a few filters, like, computing winds, rotating winds, and so on. I'll skip those for the interest of time. There is a very small selection. This is work in progress, and many sites have been implementing their own filters. So one which is useful is rename. Okay, now I show you at the beginning to create a data set. You do an Anemoi dataset create, and you have a massive. It may take a lot of time, so you can do it incrementally by part. And the important part of that slide is that the load that you do 1 out of 20 or 20 out of 20 can be done in parallel. ZAR allow you to write to it in parallel and as a good locking mechanism. So usually if you really have a very large data set, you call init, and then you call load as many times as you wish in parallel. And then there are a few more calls once it's all finished to finalize and clean up any temporary files. Now, the idea of those sources and filters is that we want people to contribute new sources and filters, and we are going to work on a plugin system so you can implement your own plugin and filters, and then maybe contribute the plugin. Now, a few examples here. Just this is okay. It's, the recipe are in YAML, but here this is a sort of flow chart. At the top, you have the date coming in, and then you have, in that case, it's a recentering. You have the members. You see a few Mars requests, and then they are passed to a recenter function, which is we will also add the four things, and we create a data set. Another one here, which will get data from Mars, from an experiment. This was actually an ocean forecast. And then we needed to add a few netcdf, like the bathymetry. So we have those blocks which repeats the bathymetry, and they're all fed to the data set. And the last one is one done by MeteoSuisse, just to illustrate that they have added their own source, which is in that case is Kenda, and they have added their own filters to interpolate and then to convert the winds and so on. These are filters and sources that have been developed at MeteoSuisse that they run directly to create their own data set. And these are just easy extension to the system. And that's my last slide. Any questions?
Thanks, Baudouin. That's very interesting. We have had many questions in the chat while you've been talking, and colleagues have been answering them. There was a couple of questions that were passed on as maybe you could discuss a little bit further. So one question that we picked out was from Thomas, which has already been discussed a little bit, but the question is, to create a data set, several sources are working perfectly, GRIB, Mars, and so on. but what if I want to use more exotic sources, e.g.
Okay.
TIF? And more generally, is there a way to write an Anemoi data set from data I can load into a NumPy array?
Okay, no, I mean, what I wanted to say here is that the code is object-oriented, okay? And the slide is this one here. I think we've been already, a few people have contributed filters and sources already. So either you convert your exotic source to netcdf or grib, and then you are in business, or you want to go and get directly from your source. And as I say, we are planning to implement a plugging system. So you just write some Python code, drop it in a directory, and we find it. We can run your code. Remember that, I mean, we have lots of ideas. This is work in progress, and every feedback will be useful. So what I say in the second bullet here is that if a source of a filter is of general interest, they should be contributed, okay? If it's just for your source in your site, then they don't need to be contributed. Then we should use the plugin system.
Okay, there's another couple of questions, and if anyone feels brave and wants to raise their hand, we could also potentially take a question like that. But in the meantime, the last 2-3 that I've got here. So there was a question from Alejandro, and it was discussing building Anemoi datasets from grib files, and the question is whether this leads to data duplication. He says, it seems to me this leads to a lot of data duplication and extra storage unless I'm skipping that an Anemoi dataset could be created iteratively as an X-array ZAR.
I mean, the comment is correct. It's data duplication, okay? Because, and that's by design. You cannot train your model from grib. It will be too slow. First, you need to find your fields, and you need to decode them and so on. So the idea, that was, I think, my second slide. You really have to see those data sets as a pre-processing to your model. You have data all over the place from different sources. You want to train a model. You want to, your model may train for a couple of weeks, and you want to go as fast as possible. So you prepare the input to the model. This is really the vision we have for those data sets. They are something that you prepare so your training is as efficient as possible. So we will not create a data set and delete the original grib ever, because the original grib for us are the true source of the data. But I mean, you can do whatever you want, but in your site. But that's what we see. So at the end, we create a data set. It's on disk, and we can read it as fast as we can.
Okay. So I've got 2 more questions in the chat, and then there's one person with a hand up. So let's see if we can still manage those. The third question is, if only valid dates matter for definition, is there a simple way to build a data set from reforecasts, e.g. daily forecasts at plus 48 hours lead time, where valid times are associated to 2 data points?
Okay, we have done something like that. It's very hacky, because at the end, what you want is you want the state of the atmosphere at a given date. So if you have a reforecast that happens to overlap, where you have 2 reforecasts that validate at the same date, which one is the right one? We had a lot of discussion like that. Okay. So if people have ideas, what it really means, you know, is it the 1st of January from this reforecast, or the 1st of January from that reforecast, and which one is the one you want? Okay. So if you have reforecast and the valid time don't clash, then there is no issue. You can build a data set. But if they clash, they try to go into the same row of the data set, and that would be an error. So we have a hack around that, but it's really is a hack, okay? And we are thinking about it.
Okay, so last one from the chat for the moment. I don't think this one was answered that I saw. So it's from Jose, and it says, imagine I've created a data set with Anemoi datasets, and I would like, for instance, to remove a specific variable. Of course, I can do this with Anemoi datasets as seen today, but is it possible to update the ZARF dataset regarding this change? I mention this because I'm used to work with YAML files, and as far as I know, in these files, I have to indicate a path to the ZAR data. I do not know to what extent it's possible to specify in these configs these operations over the data. I
mean, yes, you can. If you want to remove a variable, you just call drop. I assume that you remove it virtually, not physically. If you want to remove a variable from a ZAR, you need to recreate one. Otherwise, the way and I think that will be shown during the training, Anemoi training, people describe their input with a dictionary in YAML that selects a couple of data sets and drop a few variables and change the frequency and do all those things. So I hope that answers the question. If you really want to recreate a data set with less variable, the only way now is to just recreate one.
Okay. So there's someone with a hand up, so I'm going to see if they can come on. It's Surya. I'm just going to activate the mic and the camera. Surya, are you there?
Yeah. Hi. Thanks. Thanks for the session. I just have a quick question. I don't come from the weather forecasting background, so my question could be naive. My question is, during the training of the model, I've seen that the data set has all the attributes with regards to variables and the grid points. What I wanted to understand is, when I'm training the model, where do I exactly store the target labels? Like in
we don't have labels. In our case, in Anemoi, so far we don't have labels. We only forecast, given the weather now. The forecast is what will be the weather in 6 hours. So it's if you want, I mean, it's a simplification, but the input and the output are the same.
Okay.
I mean, it's not 100% true what I'm saying. We can forecast new parameters, but you have temperature, pressure, wind now, and the output is temperature, pressure, wind in 6 hours, and that's how we train. So that's why our structure works well, because you just take 2 rows in the data set. So if you want, the output is the input.
Gotcha. Thank you.
Okay, I think there's just one more. Maybe if we've just got time for one more question, Baudouin. I saw one more in the chat, and then I think we might have to close there because I don't want to go too long over the time. But someone's just said, they say, before creating an Anemoi dataset, do I need to reproject all my inputs to the same grid?
Yes. Yes. I mean, the dataset expect all the data to be on the same grid. But we don't care about which grid it is. So, and in a way, to be fair, we just use the grid of the first field we see, and we assume that every other grids are the same. Okay. So, but we have no. The grid could be anything. They don't have to be structured. They don't have to be regular. They just are. And I think that's what will be explained in the Anemoi graph, because we build a graph from the list of lat long eventually. So it doesn't matter what grid they are, as long as they are all the same.
Okay, I think in the interests of staying kind of on time. I think we might wrap it up there for the moment. I just wanted to, before we close properly, just say first of all a big thank you to Baudouin for his presentation, and to all the colleagues who have answered all the questions in the chat, and of course to everyone who's come and listened to the webinar and asked all the interesting questions. So thanks very much for that. Once again, we have a very, very short survey if you want to leave any feedback on the webinar. So if you scan that QR code or go to that link, you'll be brought to a survey with just 2 questions and 1 little box where you can leave a text comment if you want. We'll also send a recording round afterwards with this survey link, an email with the survey link, and in the next day or 2, we will publish the recording of the webinar and the slides. So I think with that, I would like to just say a big thank you to everyone again, and we will now close the webinar. Okay, thanks and goodbye.